Hello students, hope you are doing well. Today we are going to solve one problem. A rectangular plate with two circular holes subject to a uniform tensile stress of 250 Newton per centimeter square as shown in figure. The thickness of plate is 0.5 centimeter. Young's modulus is 2.1 into 10 raised to 7 Newton per centimeter square. Poisson's ratio is 0.3. Perform the statistic analysis and calculate the deformation. So this is the plate having 10 mm width and length is 7 plus 7 plus 7. It means 21 centimeter and it has two circular holes. Now we are going to solve this problem with in Ansys APDL. So we will first open this Ansys APDL and here we start with the preference. We have to do the structural analysis. So structural analysis H method, okay. Then in preprocessor select the element type, add element. So here we are going to add element. This element is solid and quad 4 node 182. Say okay. Now you can see here the element is there. So options we have to want the thickness also. So plane with thickness. So we will select this. Say okay. Close this. Next is we are going to add the thickness. So add, select this element. So in the real constant we will select this. Okay. So it will ask me thickness. So thickness was given, that is 0.5 centimeter. So we are going to plot 0.5 centimeter. So all the units are in centimeter, so we don't need to worry. Okay, Ansys. So close this. Next is material properties. So select material model. In material model, structural, in that we have to go to linear, elastic and isotropic material we are going to consider. So this E, okay, so this is 2.1 into E7, 2.1 into 10 raised to 7 and Poisson's ratio is 0.3. Say okay, close this. Once you complete this, save, make save db. So your program is saved up to this process. Then in modeling we are going to create a rectangular plate. So here we are going to plate modeling, create area, rectangle, select corner. So one corner is 0 comma x is 0, y is 0. What is width? Width is 21 and height was 10. Say okay. So this is rectangular plate. Now we want to do the circle. So create here circle, solid circle. So what is this x distance? So circle is at 7 centimeter from this and it is at a center, that means from axis, and it has radius 1 centimeter radius. Say apply. Similarly another circle is at x is 40 here and y is 5 and another radius is this. Say apply. Okay. Now these are the circles. Now here we have these circles, there is hole is there, so we have to apply the Boolean operations. So in modeling there is operate is there, Boolean operations, subtract, select the area. So this area is selected. Okay, so this area is selected. Say okay. Which area we want to remove? This and this. Say okay. So this circle area is removed. Whichever area pink, that is get selected. So first we select whole plate area, then we select the second area. Now I will do the save db. Once we complete the modeling, we are going for the mesh. In that I will select the mesh tool. in that we have to select the set area. So area set here, select this area. Okay. Now element length, I will provide the element 0.4. Say okay. Now again I will mark this. Okay, or you can mark here also. So here we want the quadratic meshing. Okay, and it should be free. So I will say mesh, select the area, this area. Okay, now this meshing is applied. Now next is we have to do the loading condition. So now here in loading condition, define loads. Okay, so I will select apply in that structural. So here we have to one is we have to do the displacement, another is the pressure. So first is displacement. So I will say displacement on line, this 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 this, select this. Okay, so here all degrees of freedom. Okay, so here if you don't put any value, it is by default 0. So you can say okay. So these nodes are fixed. Now next is pressure. So we have to apply the pressure. Select pressure on line, select this line here and this here. Okay, so here pressure value we have to write minus 250. Apply. Okay, so you can see pressure is applied. Next is we have now next is we have to go for the solution. So solution, here we solve, we have to select current ls. It will ask you begin the solution of current load step. Say okay. Now solution is done. Okay, so our solution is done. So now we will take the result in post processor. So general post processor. So here we can say result list result. So here we can say nodal solution. Here we will check the degrees of freedom. So degrees of freedom in y direction, say okay. So you can see here these are the nodes, and okay, there is their displacement. Again if you see here, plot result, deform shape, deform, undeform. Okay, so you can see this is the deformation of shape. So again nodal solution, if you want degrees of solution, displacement vector, say okay. So you can see here this is the displacement, here 0 deviation, but here deviation is maximum. Next is if you want the simulation of this, so we can say here plot, animate, deform shape, deform, undeform shape. Okay, so you can see here this is the simulation. Previously it was this, and now this is the deformation which takes place. Okay, so next is close this. Again we can see the stress. So select this nodal, in that we are going to see the stresses, in that we are going to see the Von stresses. Okay, so you can see here, so maximum stresses are occurring in this area. If you want to save this plot, here plot control, write meta file, invert file to black. So here if you say here, so this is the file on the desktop I am saving. Save this. I can open this file. So this is the file, open with pen. So you can take the printout of this. So you can see this is the minimum stresses, this blue, and this is the red is maximum stresses. So that's it.